Let's talk about admission controller. Um, there are various forum, blogs, video blogs, YouTube articles available on admission controller. In fact, Kubernetes reference documents and blogs are a very good source of understanding what is admission controller, what they do, how to set it up. But still, I do see same questions frequently been asked personally, frequently, and that's where I presume or I assume that there are some gap in information or communication, maybe the way it's been mentioned in various documentation, and I can see that there are certain clear misunderstanding everywhere I go. So I would try to give those answers, and that may help others to understand. And I would expect less questions in this regard um, in future. So basically, if I sum up all the questions is getting asked like, what is admission controller? Remember, as I said, like there are very good documentations and places where you will find these answers. I won't even need to give you this URL. It's just a one Google search away. What they do, how they do. These are very important, and there are various way to make you understand those. And that's where I'll not start with explanation. I'll start with a concrete example and how it has to be set up, because that's where uh, these two questions, I believe mostly people are sure about these three questions, but mostly what happened is that this question fifth and question sixth actually makes things complicated. H- how how many different kind of controller do exist, right? And for each of them, what are the different settings setup is expected, right? Because there are uh, two different kind. One is dynamic admission controller, one is simple admission controller, right? Admission controller, dynamic admission controller, validating and mutating. And then you have something called open policy agent, right? So how these three are different? If these are the same thing, maybe of different potential, and how to set it up. Set up, actually, why it is pretty messed up, because if you say how to set up, Kubernetes admission controller, the first thing you would see is this one. How do I turn on an admission controller? Now that's it, right? Kube API server. Where? So let's say you have a cluster, right? And you have your own terminal. So where do you fire this Kube API server enable admission plugin, this command, and how it work, how it's supposed to work? You know, what is the proper way of enabling this, right? What is the proper way of turning it off? Where in the life cycle of provisioning a cluster it should appear? It do not answer those questions. So for a beginner, it's a challenge. For an organization which is adopting Kubernetes, it's a challenge. But believe me, all the answers are here in the Kubernetes site itself. But still, it seems like there are a lot of confusion around it. So I'll start with that. I will start with how to set up. Then I will set up one single admission controller. We'll see how it affect. Then in different series, because these three will take its own course or own uh, time to do a valid explanation. So I'll start with how to set it up, and then slowly I'll go into defining and implementing all these three different kind of admission controllers. Maybe we'll find these three are same thing. Maybe the potential is different, right? So while I, while I'll be doing that, naturally these three questions will be answered if you do not know already. I believe most of the people do know what is admission controller. So basically, if you want to fire a kubectl command to create an object, right? You want someone to, let's take this picture. So when you are firing a kubectl command, that basically goes to kube API, right? If I go to this one. So when it goes to kube API, Kube API has nothing more to do if the user already been authenticated and authorized, other than deploying, creating, or deleting whatever the request you have to listen to that, right? But you need some gatekeeper, to check if it is violating any of the rules you have implemented. Now, what are those rules? Let's say you want image to be pulled always when you are deploying, right? Or let's say you want a deployment object to have five different specific organization specific label or annotation to be incorporated, right? So all those validations would happen. If it is not violating any of those, then only it will get administered, right? So that's where you would see that validating admission is happening here, and then only it is persisting in etcd. But before that you have mutating. So the problem with this picture is, if I start discussing what this mutating admission does, what this validating admission does, it will be a theoretical approach of explaining things. But I want to take a more practical approach, hands-on approach. So I'll come to this picture later on, but maybe during answering this question number 6 and question number 5, you would see that this 1, 2, and 3 questions also getting answered, right? So now let's start with how to set it up. Now for set it up, there are different kind of Kubernetes deployment, right? You may use Azure, GKE, AWS for the cloud provider, where you have different flavor like managed, unmanaged. Like in case of Azure, you have managed AKS, where you are not in charge of the master node, where Kube API server basically resides, right? So you do not have the that capability to enter into that server to configure any of the stuff. But in case of unmanaged, like AKS engine, where you can use the AKS flavor, but you can manage master node and everything, the approach will be different. Same way, GKE, AWS may have slightly different way of managing it. So and this depends on individual documentation. But what is that portion or the component you are dealing with? To get that understanding, I would prefer you start with kubeadm. Kubeadm, a famous tool, uh, most popular tool to provision spin off your own Kubernetes cluster. So if you understand how kubeadm create the cluster, and exactly in the life cycle where you should enable that plugin, that will give you a clear understanding that in case of all other distributions, how things may turn up for you. So like ADM, there are other provider, like for from Rancher you have K3s, right? So so you have plenty different ways of provisioning Kubernetes server, and based on that, sorry, Kubernetes cluster, and based on that, enabling of the plugin, though it will affect the same component, the approach will be little bit different. So I'll like to show you how you can do if your cluster been provisioned based on kubeadm. So let's start from there. So to understand that, one thing you can do, The Kubernetes IO has a nice article for a starter. This particular URL, which I will post in this YouTube video, under this YouTube video, you'd see, famously used tool Vagrant, which is very easy to use. How can you provision a 3-node Kubernetes cluster with Ansible playbook, right? Mostly the script I'm going to show you will be same, uh, but you would see a difference. So let me explain. So the first starting point is this Vagrant file. I'll quickly go over it. I'm using virtualization KVM, and the provider is lib libvirt, using Ubuntu 18.04 image, to worker node. So this is on a loop, right? And one master node. It's not a HA cluster. It's in my home lab. Each of them has, like, 4 gigs of memory, 2 core of virtual CPU. And when I'm provisioning this, I'm actually calling playbook. So for master, the playbook name is master playbook. For each of the worker node, it is node playbook. So let's go to the playbook. You see, it's actually doing this few basic things which you could have done manually, right? It's installing all the necessary packages. Not all of this, don't get distracted. Not all the packages are required to for a basic Kubernetes setup like this iSCSI one. But anyway, installing packages, then installing Docker, signing key, then getting the latest release, then getting the stable version, then installing Docker and its dependencies, Docker C, Docker C, CLI, right? And then configuring systemd. Just for the sake of continuity, let me show you what exactly happening in the systemd section. So basically here I'm updating the native C group driver to systemd, storage driver overlay to preferred for Ubuntu flavor. I'm also doing something with mount flags, but we can ignore it at this point of time. Now I'm also creating a directory for the Docker daemon. So let's go to the master playbook YAML again. Once that systemd is done, I'm restarting the Docker, enabling the Docker, removing and disabling swap, and then I am actually doing everything for the Kubernetes to be set up, and for that all the packages getting downloaded, kubeadm, kubectl. Then I'm restarting kubelet. Once it is done, the main line which will actually provision or bootstrap the Kubernetes master is kubeadm init. Now in this init, I'm passing a configuration file, right? Cluster configuration, in short ccconfig.yaml. Kubeadm init ccconfig YAML. So it will look into this ccconfig YAML and initialize the Kubernetes master. So what that ccconfig YAML do say about it? It's actually a cluster configuration YAML, where I'm saying, at any given distributions, I want to use the stable one. I want to target the stable one, and then enable admission plugin. So if you see over here, Kube API server enable admission plugin, that basically should comes under cluster configuration, like enable admission plugin and whatever plugins you want to. Now again, I still owe you an explanations what all these admission controller do and what are the difference between each of them. But for the time being, this is the place where you would say you pass this extra arg saying enable admission plugin, advertise address, whatever, then networking. These are not of any priority here. The fact we need to focus on that how we are supplying some arguments which is overriding API server default arguments. So I'm saying that I need these plugins to be enabled, right? Now, what would happen? The kubeadm will initialize the Kubernetes cluster over here based on this configuration file. Then it will create, it will print the joint command that will get downloaded to my local machine. And the same thing will get copied to the node. So the node playbook, you will see mostly same thing, same packages, same tools to be installed. And then only thing it will do, it will just run the join command, which has a token, right? And the address of the API server. So the token, address of the API server, all these things will do something and add these two worker node to that cluster. So the place where you should do it is where when you are initializing the uh, kubeadm init and you are providing some arguments to override kube API server, default arguments, and you are saying that these are the plugins uh, I should be enabling. Now, how do you see? So once you do it, we have this many namespaces. So one of the namespaces definitely going to be your uh, and one of the pod you would see. So if you go, you'd see that the server, sorry, the pod having the same. Okay, sorry, I may have Cube API server. Sorry. So you'd see that those admission plugins are enabled. So you should not be, so for temporary measure, if you want to try something, you can definitely make the changes here directly, but it won't sustain. If pod restarts, I know it will go back to the one the way it's been in provision. So any changes you do, the recommendation would be to make the changes here in the cluster configuration YAML, right? Okay, so now when we know that where and how we should enable admission plugins, we'll do we'll disable it and we'll see one deployment. We'll see the requirement it has to validate that deployment, and once we'll enable it back, how it actually make the required decision or changes, right? So to do that, let's do uh, comment it out, and I actually run a Jenkins job. So this is the first time and last time I'm gonna show you this job because it will take some time. I'll fast forward it just to let you know like how things work in completion, in totality. I'll show you that how this Jenkins job actually do provision the cluster. So this time I'm completely commented out that enable portion, but still uh, KubeADM will enable the default uh, plugins, which is the this one, node restriction. If I'm not supplying any extra argument, I'm not overriding anything, then admission plugin node restrictions will be remain enabled. So for that, this is the job. We'll go to the configure part. We'll go to the configure part and we'll see like only seeing kit is setup.sh, right? So what is that doing? So there are a lot of things. Only things it is important is that it's running that Vagrant script, right? It's running. At first, it is destroying, then it is updating, and then Vagrant up. Then it's making the changes in my kubeconfig to merge the newly created cluster. Then it's installing Metal B, a layer 2 load balancer. I'm provisioning a layer 2 load balancer. Then uh, then so this config is actually configuring the Metal B in a IP range to show you, or we can skip that part because that will just uh, that's not important for this particular session. And then I'm creating a Longhorn, and this is something else for my storage. And then I'm installing certificate manager in a cert manager namespace. So that's it. So this particular script basically creating the clusters with few add-on. One is Longhorn storage, and it's also installing Metal B and also installing certificate manager. So that's what. There are few more things I do, like I deploy ingress, I deploy some applications to do certain stuff, but mostly for this part I commented all these things out. Only thing will do work is this Kubernetes setup with kubeadm, and let's see how it works, right? Okay. So I'll fast forward this entire job, and then I'll explain few portion of the entire log to make you understand what exactly happened. Okay, so now we do have the cluster provision. Let's just go through the entire process. So as scripted, it actually removed all the nodes, updated the Vagrant box Ubuntu 18.04 image, and then it started provisioning the cluster. You'd see it's actually configuring system D, removing swap, and stuff, enabling Docker. I'll just ignore this one. Ignore this one also. This is nothing to do with the actual provision. So this is the default kubeadm config. You see, and then metal be configured, longhorn configured, certificate manager configured. Okay, so if I just now do a, so what's happening once it is getting configured, I'm also merging the kubeconfig. So context now set to the newly created cluster, switching the context. So this is also in the script. So if I now see my config get contexts, sorry, you'd see it's automatically set up to this one. So if I just go and fire, go on to get pod on system. Describe pod. So without any kind of overriding or supplying any argument regarding enable admission plugins, let kubeadm just to enable the default one, which is node restriction, right? So now I'll try to show you certain application deployment where I need some validation, but it won't occur, right? So I believe all the nodes are up. So let's examine what exactly I want to do. So in the same repo, I do have Kubernetes apps. So it's very simple. I have two deployment. One is Hello Kubernetes first, where I'm saying imageful policy always. Another one is uh, imageful policy never. Same thing. It's saying Hello Kubernetes second, but the Docker images are same. Okay. So what I would do, I'll just create a namespace. Ctl create ns home apps, and then okay. So if I just get all the pod, I see this is the pod. Let me just still creating. You see it's saying error image never pull, right? So the second one I said like never pulled the image. That's why it's not getting the image. But later on, it's running only because the first one pulled the image because it is the same image. If you have noticed here, it's the same image. So this is a potential security violations, right? It says never, then it's actually using the image. The first deployment is pulling, right? So if I check both of these, one of the pod at a time, if I just do describe describe pod B pulling image, successfully pulled image, right? Now the same thing I'll do. Second, oh sorry, and what it's saying, error image pull, container image, successfully assigned home apps. It's, it's not actually pulling the image, right? If I yes, successfully assigned home app, container image hello is not present with pull policy of never, then it is getting an error. Then it is using whatever already present on machine, right? Whatever already present in the machine, because the first one pulled that image, and that's what this deployment is using, the second one. But it actually failed uh, to pull the image first because it says never do pull the image, right? Now that is one. And second thing I would like to show you, uh, for that I may need to do a full-blown deployment just to make you understand the use case, right? So now this is just an deployment, right? So uh, for this particular cluster, I already had Metal B load balancer deployed. So when I deployed Metal B, I am expecting that if I deploy a Kubernetes ingress controller, that will bring up a public IP for me. So right now, if I try to see if there is anything available, any kubectl get svc. So there is only cert manager, home app, and kube system, right? Longhorn, I do not want to discuss right now. That's not relevant for this particular session. So let's deploy an ingress. Now, to deploy an ingress, rather doing through Helm, because I also would like to show you something. So first thing you see that if I say image pool policy never, it's actually try to do that. But my intention is that all the deployment, irrespective of their image pool policy, it should always pull the image. So keep that in mind. Number one use case is that use case one requirement is to pull image always. We'll see how it work. And use case two is something to do with validating ingress. Now, rather explaining, I would show you what I would like to do. So for that, what you need to do is that uh, we need to deploy uh, Kubernetes ingress controller. So for that, rather doing Helm, we do it long script, and I'll show you why. So in this script, there are two services. So this script basically a script to deploy ingress engines in bare metal, right? So it will create a namespace of ingress engines, and then it will deploy the entire stack of Kubernetes ingress controller. So there are two services. Um, Two services. One is ingress engines control admission. Another one is uh, ingress engines controller. Now, the default script from where I copied, it had this node port, but I already have metal B in my cluster, right? So if I change that node port to load balancer, which I did already, then what's gonna happen, right? So let's see that. So if I go back, there is a deploy ingress sh, and if I go here, see, this is the default script, original script I downloaded in my home lab, and I changed that admission controller service type, right? Let me show you service type. So why I'm actually doing like this, not with the Helm, just to give you an overview how things work underlying, and there are certain problem with the Helm package with admission controller. That also I'd like to explain. So this one is node port. If you see, ingress engines controller is type is node port, but I want it has to be a load balancer so that I can get an IP, right? So that's the changes I have made, nothing else. And now I'm going to deploy that. So So Metal B giving me a external IP address. Now, how Metal B giving me that? To explain that, we need to go to the load balancer. As I said, I installed Metal B, and then I'm configuring Metal B, right? So the configuration of the Metal B is like this one. It says the address pool, the protocol layer 2 address pool is 192.168.51.20 to 250, right? So in that range, it is taking the first one, and as the controller is load balancer kind, it giving me a IP address, right? So now the ingress controller been set up. So if I set up a ingress, definitely it will give me the expected result. So what I want to do is I want to those application I just deployed, that hello Kubernetes. If you see this application, hello Kubernetes first, hello Kubernetes second, all these are deployed. It also deployed with the services, right? So each of these service actually point to or abstract this deployment, right? Uh, hello Kubernetes first selector, right? Target port 8080, port 80. So now I have service and deployment in my home app. What I want to do, I want to deploy ingress object which will actually render this application UI in a different path, right? So to do that, I need to deploy an ingress. So we'll go to that. Uh, and let me go through that first. And I also want to configure TLS, right? So this is the way uh, it will look like. So ignore about this Longhorn UI. This is something to do with my storage, as I said, keep on saying again and again. So the first thing is that my TLS host name are sample3. Sample3 will point to hello Kubernetes first. Sample4 will point to hello Kubernetes second. The secret name where the certificate will be stored or hold, it is like this is the name, and the rules are, if someone is looking for sample3.vinepro.local, uh, point them to hello Kubernetes first. If someone is looking for sample4.vinepro.local, point them to hello Kubernetes second. So just for the sake of continuity, I already configured my host file with the same IP. That is done. But to TLS to work, now this is where my apology, I won't go much detail. Uh, uh, so I'm using my own CA root, and I'm creating my own certificate. I also have cert manager, right? So I may explain the entire step in a different video, but for the sake of this one, I would like to tell you that I have certificate manager, which basically deals with creation of the certificate, sorry, uh, 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 requesting the certificate, getting the certificate, and implementing the certificate. The way it works is that when I try to deploy um this particular ingress, the ingress will try to use this issuer to get a certificate issued, right? So the ingress will try to get a certificate by this issuer. Now, the issuer will issue the certificate based on this host name, right? Now, how do I create this? So then I need to create this issuer first, right? So to create this issuer, let's go to if I go to TLS, then I do have uh, this issuer, right? So this issuer object require, so I could have said self-signed, right? But I do not want to do a self-signed. In that case, in the browser, you would see a ugly error message that it's a self-signed certificate. Sometimes there are problem of recognitions, right? So I would like to create a issuer which actually use a certificate authority uh, based on a secret, the name of which is TLS key pair. So basically, issuer will issue the certificate, but before that, it will go to a certificate authority, submit the certificate request, and get the certificate for that particular ingress, right? Now, how do I create this secret? So for that, we'll go to the namespace folder. I do have this deployment script already ready. So the first thing is that I need to create a TLS secret, and this is where I have kept my uh, unencrypted CA root key and certificate. So this is where I'm saying that I will create another video where I will explain that how to create this certificate key and certificate itself, means root CA key, root certificate itself. So once you have this certificate, you can definitely create your own secret, TLS secret. So that's what I'm going to do right now. So now once the secret is created, you would see that it has this TLS star TLS key that is based on the certificate authority key and the certificate I created, right? So this is where our issuer will look to get a certificate issued, right? So let's go to the issuer and try to create that issuer. So I already have the script over here. That is creating issuer, right? kubectl apply issuer. Let's create that issuer. The issuer created. Now if I signing CA verified, right? So this certificate authority came from this particular secret because this secret been created with the CA root key and CA root certificate. So I have the issuer, I have the secret. Now it's time to deploy the issuer, right? So if I deploy the issuer, and right now, if I do a kubectl get secrets, I see I have this key pair, right? If I say get certificate, I have none. If I say certificate request, I have none. So let's just go ahead and create this one. Oh, it's not the issue. Sorry. I have to create the ingress. Ingress. Sorry. Hmm. Let's deploy the ingress now. Ingress is created. So I'll check for that certificate request. You see, our certificate request generated, ready. And do I have the certificate? Now I should, right? Certificate is also been generated, right? So if I describe been successfully issued. So issuer, with the help of this particular secret, which has been created out of my own CA root key and CA root certificate, issued at first, it created a certificate request. Then based on that, issuer issued the certificate, which is this one, successfully issued. So now, based on that ingress itself, if I go back to that ingress, which is expecting this issuer to issue the certificate, everything should work, because over here I have said, like, if someone is asking for sample 3, then move him to hello Kubernetes first, right? So if I just do this curl https sample3.bindpro.local, so I'm getting hello Kubernetes first, right? And one more thing, if I just do this, this is the second one, right? And if I now do this Kubernetes kubectl get ingress, you'd see the ingress host, these are the host configured, and it's getting exposed through that ingress load balancer ingress controller service. uh, 192, because metal b has. So now why I'm showing this deployment right now, if you remember, the use case 1 was the image pool. I said for one of the use case 1, I said, like, image pool never, so it actually went by that. It didn't try to pull the image, it failed, and then it used the existing one from another deployment, right? And the use case 2, I would like to show you that something to do with the ingress. What is that? That I do have this ingress which deployed, which is correctly rendering TLS secured website. But if I try to inject some malform from gibberish, what would happen, right? So if you see, this annotation is a valid annotation, but this blah is not a valid one, right? So if I try to deploy this, now let's redeploy or reprovision the clusters with all the plugins enabled, which I intend to show you. One is always pull image admission controller, then a default ingress class, as well as mutating admission webhook and validating admission webhook. I won't be showing you anything regarding this one in depth. That would be for the later part of the videos in the series. You definitely see something regarding default ingress class as well as validation admission webhook, that how it works. So let's do reprovisioning once again, and this time what I would do, I would configure to deploy all the necessary artifact. So I'll deploy the Kubernetes setup, which will deploy provision the Kubernetes cluster as well as Metal B load balancer, certificate manager. Then this one will deploy the ingress, Kubernetes ingress Nginx controller, and this one will deploy, you know, uh, few applications. and we'd observe that how everything is working. So everything will get destroyed and get recreated. Let's start the build, and it will take some time. I'll switch it off and come back and resume once it is. Okay, now that I have recreated the entire cluster, uh, this time if you remember that I already deployed all the required artifact. So once again, just to give you a recap, last time I deployed, first time I deployed with default admission controller. So the application I deployed, one the deployment, the first deployment had image pool policy always. It pulled all the images. The second deployment had image pool policy never. It failed first, but the moment the first deployment downloaded the image, it was able to provision itself, which was a clear violations, right? Now I also deployed an ingress, and I told you that something I would do which will show that ingress validation controller can put some control over how you want to define your ingress object, right? So in the second provisioning of the clusters, I have all the admission controller enabled, right? So before I show you that, let me show you what's been deployed. So the cluster's been provisioned with Metal B load balancer, certificate manager. Then ingress has been deployed. I already went through that ingress script, and that ingress had few component which I will go through later. And then I already deployed those Hello Kubernetes first and Hello Kubernetes second, right? And one deployment had image pool policy still showing always, and the second one had image pool policy uh, never, right? So let's see what had happened. So if I try to get all the pod from namespace apps, these are the pod, and let me still uh, describe the first one. Okay, let me do one thing. Let me remove the deployment because the thing I want to show you, I'm not able to show you right now. So let me simply redeploy this application once again. So how do I do that? I will go back to and this is the one. So I'll simply remove it and then I'll redeploy. Okay, good. So let me check. Okay, so there is no deployment or pod available right now. So let me just go ahead and create this enter deployment once again. And we'll quickly check what's in the description. Well, so the first one successfully pulling the image, which is expected because it had image pull policy always, right? So that is expected. And if I check with the deployment, it is always, and I can check the deployed version of it. So get. So if I just check it, I would see the image pull policy is always, always. Now for the second one, second deployment, image pull policy is never. So let's see. So the second one is describe, any of this would do. Pod, is saying successfully assign pulled image. Fine. Let's see what's been deployed, right? Now, based on this artifact before it's deployed, it's saying image pull policy never. But if I just go here, it's saying image pull policy always. And you see this value hello from the sample to ninth time, it match here. So definitely someone or something has changed or mutated this image pull policy never to image pull policy always. So that is working. What is that working? That's the image pull policy admission controller, right? Admission controller is already built in with the Kube API server, and we are not using any web hook, or we are not extending any feature to do that mutations, right? So if I go to Kubernetes setup, you would see this always pull image is doing its job, and no webhook service is involved because I don't see any log recently, right? It's been created, sending update to CC, it's been created, but there is nothing I can see regard to uh, that. So there is one like to see rejected by valid and injects ingress. So this is related to ingress, and we'll come to this one later. So at least for the time being, this particular always pull image admission controller working. Clearly it is mutating, the image pull policy. Now let's see what about this validation, validating admission webhook, and how it's working, whether it's working or not, right? So for that, what I would do, I'd go back to my ingress, and I already uncommented this part. So uh, this is a malformed word I have incorporated, and if I try to deploy this ingress, it should fail, right? So I'll take the raw URL and it's actually throwing an error saying error exit status 1 unknown directive blah, which is as expected, and it failed, right? Now at this very moment, I'll again go back and check the log. So the log, if you see, let me rejected webhook, unknown directive, dispatcher, it failed. Now, if I make change to correct this one, it's working. And to check it is working, so it's working. Now, these two is working, right? Mutation is also happening. Now, we know what happening with always pull image. Let's understand what's happening with validating admission webhook and ingress, because this is where there are some contradicting informations in the internet that how we supposed to enable the default very basic uh, check of ingress object malform validation, ingress validation with validating admission webhook. So for that, how it is working, we need to go back to the long script of ingress engines deployment artifact, right? So there are few particular thing. At first, we would actually have this picture side by side, and then we'd see like how we can get sense out of this long script. So first thing, so API request happening, then the person, it's me, who is firing the kubectl command has already been authenticated. I'm authorized to fire or delete, remove, create all those object. I do have those, that's for sure. Then this mutating, at least for ingress, this mutating admission is not coming into picture. It is going through this, but it's not taking any, it's not doing any action here, because I'm not trying to mutate my ingress object. I'm simply trying to validate my ingress object. So it will directly go to validating admission and try to validate the schema object, right? So how it's working, this validate admission will call this webhook, will call this webhook, this validating admission will call this webhook in secure fashion. So first of all, would need to see how this validating webhook configuration is configured, right? So the name of this one is ingress engines admission. It's saying that match the policy equivalent while creating or updating any ingress object, and fail, which is happening. In case it's not matching, or in case it's not a well-formed ingress object, right? So that's what this validating webhook configuration is saying. That's it. Now, this configuration to take effect, a webhook service needs to listen to the request. That request actually has this object schema into it. Webhook service will look at it and then it will try to validate based on this validating webhook configuration. So how this webhook service is getting configured? So first of all, before I go there, let's check this validating webhook configurations, right? So I would expect there will be two, because certificate manager also use a validating webhook configuration. So let's see. And ingress engines admission. If you see this ingress engines admissions, right? This one is of our from our ingress deployment, ingress controller deployment. So let's see, kubectl describe. And it will actually show you the same thing, like whatever uh, happening here, right? So if you see this, I'll explain that what this CA bundle means. But mostly these configurations will work when the service of the webhook for the webhook is working, right? Now the service is this one, right? Ingress engines controller admission, right? Now, what does it abstract? That is the deployment. This deployment. This is actually deploying the the webhook controller, or the actual ingress engines, right? So it's actually pointing that deployment. So to show you, ingress engines controller admission. Now, the way it works, this service basically represent this webhook service here. But this communication between validating admission and this webhook needs to be secure. So that to be secure, you need certificates. You need TLS based encryption and decryptions to happen, right? So for that, you need a certificates to be created. So there are certain script I have seen in various places, but the good thing is the latest deployment or the latest script do have these two job, which actually provide you with the required certificate. When it creates the certificate, that certificate supposed to include the CNAME or the common name, and that common name should represent the webhook service. How it work? The service name we have seen here, ingress engines controller admission. So that, then pod namespace, which is ingress engines. So the spot namespace is ingress engines, then the service name dot svc. So this is the API URI for the service or the common name, and based on that certificate needs to be created. That certificate is getting created by this particular image, which is cube webhook search gen, generating a CA and leaf certificate with long expiration, then patches Kubernetes admission webhook by setting the CA bundle field with the generated CA. And this can optionally patch the hooks failure policy, setting useful in cases where a single Helm chart needs to provision resources and hook at the same time as patching, right? So this one is creating the certificate based on the name of the service, namespace.svc. Now this one along with this one. So when we are getting this, the secret name is ingress engines admission, right? So if we come to the deployment here, let's see, it's actually referencing the same secret and mounting the webhook certificate here. So if I quickly check, I see that there is one certificate ingress engines admission. So just to prove that the CA bundle certificate, CA bundle and the certificate it's generated is the same, you can quickly check that. But first, let's check that the secret CA. What is the CA, right? We can see that CA here for the validation webhook. For the secret, let's see. And then we'll check what is this, what is there in the CA bundle for the validation webhook configurations, right? And these two are same. So the major concern or misdirection about this ingress webhook validation was that how to create this certificate and deploying it correctly, right? With the new deployment script, it seems like, and it's been proven that these patches, this job patch actually will create the certificates for you. Only thing you need to do, deploy the script, nothing else. We do not need to think about how security, how TLS certificate will be enabled between this, response and request loop. So that's been sorted out. So that's the way it work, and I hope this will help. Uh, And in the next part, I'll try to engage for this one, dynamic admission controller, validating and mutating. Now we know that how basically it works. So you need to have a webhook service configured. and then certificates needs to be configured. We can use the same pattern, but now we'll do something custom. We'll do something which makes sense. Like as I said, like maybe we'll do implement a policy about creating labels or default annotation based on the organization policies. But now we know that a default compiled admission controller that has their own basic objective, and then this validating and mutating basically change if something is violating the policy, and validating actually validate and fail, or maybe you can ignore it if you'd like to do that. So we'll get more detail we'll get more detail about these two in the next series.